Good day, everyone. I am Charisse Antimatango, a first year college student from BSBA major in financial management. So, for today's lesson, I will be talking about linear programming simplex maximization method using equal symbol. So, without further ado, let's jump with our equation. So, what in linear model in equation form? So the development of simplex method computation is facilitated by imposing requirements on the LP constraints. So linear programming is also known as LP. So these are the requirements uh, in linear model and equation. So all constraints are equation with non-negative right hand side or RHS. So we will be encountered RHS later. So our second requirement is all the variable are non-negative. Next is converting equalities into equation with non-negative right-hand side. So RHS represent the availability of our resources. Left-hand side represent the usage of the resources by all the model activities or variable. Next is the excess amount of the RHS over the left-hand side, then yield the unused amount of the resources. Next is converting an equality equation or constraints into equality and set up variables. So this is an example of constraints, and this constraints is we will be using also in our first problem. So let's jump in our problem number 1. So Gina is a production manager of Clear Shampoo, and she wants to determine the production mix that will result in a maximum profit. She is able to determine the data necessary for her to make a decision. It will take 5 minutes to mix one case of men's shampoo and 10 minutes to mix two cases of women's shampoo, and she has a total of 10 minutes available for mixing process per day. It will take 7 minutes to bottle the one case of men's shampoo and 7 minutes to bottle the one case of women's shampoo, and she has a total of 84 minutes available for bottling process per day. It will take 9 minutes to pack one case of men's shampoo and 5 minutes to pack women's shampoo, and she has a total of 90 minutes available for packing process per day. She will earn 6 pesos for every case of men's shampoo produced and 8 pesos for every case of women's shampoo produced. So, first step that we will be doing is we should find our or make our objective function. So, our objective function here is max sub 2 is equals to 6x sub 1 plus 8x sub 2. Then, next is constraints. This is our constraints. 5x sub 1 plus 10x sub 2 is equals to 100 for mixing process. And 7x sub 1 plus 7x sub 2 equals 84 for bottling process. And 9x sub 1 plus 5x sub 2 is equals to 90 for packing process. And let x sub 1 be the number of cases of men's shampoo, and let x sub 2 be the number of the cases of a women's shampoo. So this is the x sub 1, and x sub 2 is equals to 0. Next is set up the objective function where 0 is the assigned profit for unit of slack variable. So max z is equals to 6x sub 1 plus 8x sub 2 plus 0s sub 1 plus 0s sub 2 plus 0s sub 3, subject to 5x sub 1 plus 10x sub 2 plus s sub 1 is equals to 10. 7x sub 1 plus 7x sub 2 plus s sub 2 is equals to 84. 9x sub 1 plus 5x sub 1 plus s sub 3 is equals to 90. So as you observe, there is no other value here since the value of the another s here is 0, so I didn't put the other s pa. So next is we write the objective equation as max z is equals to, so this is our objective function. So x sub 1 plus 8x sub 2, then we need to transpose this into other side. So when we transpose the positive number to another side will be negative. So it will become z minus 6x sub 1 minus 8x sub 2 is equals to 0. So next thing is we will be doing or creating a tableau. So iteration 0, 1. So it's up to you what iteration you will be using. So you can use 1 and 1 or 0 and 1. So let's proceed to our creating a tableau. So z minus 6x sub 1 and minus 8x sub 2 is equals to 0, and we will write here our constraints. So we will just put this value into our tableau. So this is negative 6 from here. This is from our negative x sub 1. So this will be negative 6. Next is negative 8, 0, 0, 0, and is equals to 0. Then for our s sub 1, we have 5 since we have 5x sub 1 here. Then 10. So since we have 10 here. Then 1. So the value of s sub 1 is 1. And the other following values here, so it is 0, 0, and equals to 100. For our s sub 2, we have 7, 7, 1. For our s sub 2, this is the value. Then 0, 0, and is equals to 84. Next is 9. So 9, this is 5 for our 5x sub 2. Then 0, 0, and the value of s sub 3, 1, is equals to 90. So our RHS is this in this side. Then we will be using here for our next step, we will be using Gauss-Jordan row operation, that it identifies the entering variable column as the pivot column and the leaving variable as the pivot row. The intersection of the pivot column and the pivot row is called the pivot element. So we will be encountering pivot element in our next slides. So this is our table, our tableau. So for us to get our so this is our pivot column. For us to get this one, we should identify the most negative coefficient. So in simplex optimality condition, we should select the most negative coefficient in the objective equation or entering value. So this is the most negative, diba? So pivot, this is our pivot column now. So the mechanics of determining the leaving variable calls for computing the ratio of the right-hand side of the equation to the corresponding positive constraint coefficient under the entering value. So here we should find the minimum ratio from RHS. So for us to find the minimum ratio, we should divide the RHS to our pivot column. So 100 divided by 10 is 10. 10. Next is 84 divided by 7 is 12. Then 90 divided by 9 is 18. So this is our minimum positive ratio. For us to get, we should identify the minimum from this group. So the minimum for this group is 10, which is located in S sub 1. So our pivot row now is the S sub 1. And our pivot column now is the x sub 2. So this is our pivot column, pivot row. So pivot row replace the leaving variable in a basic column with the entering variable. For us to get it, we should new pivot row is equals to current pivot row plus pivot element. So the intersection, this is what we call pivot element. So for us to get the value of, so the S sub 1 will become X sub 2. For us to get the value here, we should uh, divide our current pivot row to pivot element to get the new pivot row. So we have here 5. This is our current pivot row. Then we will be dividing this one to our pivot element, which is the 10. So 5 divided by 10 is 1/2. So in other book, they are using decimals. And so, but for me, I will be using a fraction. So it's up to you if you will be using decimal or a fraction. Next is 10 divided by 10 is 1. Then 1 divided by 10 is 1/10. Then 0 divided by 10 is 0. Then 0 divided by 10 is 0. And 100 divided by 10 is 0, is 100, is 10. Next is all the row including z, or the new row is current row minus pivot column coefficient times new pivot row. Okay, so for us to get the value of z, we should subtract the current row to pivot column coefficient. So this is our pivot column coefficient, diba? So this is our pivot column. This is our pivot column coefficient. So this one, this is our pivot column coefficient. So for us to get the value of 6 is negative 6 is we have to subtract negative 6 to negative 8, which is our pivot column coefficient, times new pivot row. So this is our new pivot row, this highlighted row. So the result of that is negative 2. Next is negative 8, then divided by negative 8 times 1 is 0. Next is 0 minus negative 8 times 1/10 is 4/5. 0 minus negative 8 times 0 is 0. Then 0 times negative 8 is 0 also. Then 0 minus negative 8 times 10 is 80. For our next row, we should find the value of S sub 2. So we will be doing the same process on what we do on our last slide. So 7 minus 7 times 1/2 is 7/2. Then 7 minus 7 times 1 is 0. So it is 0 already. So when you are, it's just a tip. When you are solving the current row and the pivot coefficient, this line, this highlighted line, it's already a 0 for you to less hassle, and it's also a time consuming if you still calculate this. So it's automatically 0. So next is 0 minus 7 times 1 over 10 is negative 7 over 10. Next is 1 1 minus 7 times 0 is 1. Then 0 minus 7 times 0 is 0. Then 84 minus 7 times 10 is 14. So next is we will be getting the value of s sub 3. So we will be doing again the same process. So 9 minus 5 times 1 half is 13 over 2. Then 0, then 0 minus 5 times 1 over 10 is negative 1 over 2. Then 0, then 1 minus 5 times 0 is 1. Then 90 minus 5 times 10 is 40. So this is now our iteration 1 over 2. So in here, we just repeat the first step from the first step to the last step for us to get another iteration. So we will be doing again the simplex optimality condition, most negative. So our most negative here for our z, 0 is negative 2. So this is the last negative that we will be this is the last negative that we will uh, turn into positive. So this is the most, then negative, then same. We will find the minimum positive ratio, then also same process on how to get the minimum positive ratio. So the minimum positive ratio here is 4. So this is our pivot column. This is our pivot column now. That's the highlighted one. And then this is our new current row, pivot current row. So it's just at the same process. We need to find first the value of the highlighted row, which is the s sub 2. So this will be 1, 0, negative 1 half. So excuse me, it's just the same process. So 7 over 2 divided by 7 over 2 is 1. Then 0 divided by 7 over 2 is 0. Then the same process. So we have negative 1 over 5, then 2 over 7, then 0, and 4. Next is we should get the value of z. So it's the same process. For us to get the new row, we should subtract the current row from pivot column coefficient, then multiply to new pivot row. So this is now our new pivot row. Then we will find the value of z. So negative, this is our pivot column. So negative 2. So as I've told you a few minutes ago, so this is 0. Then 0 minus 0 minus 0, which is our current row. Then times, subtract from our pivot column coefficient, which is negative 2. Then multiply to our new pivot row, which is 1. So the result will be 0. Next is 4 over 5 minus negative 2 times 1 over 5 is 2 over 5. Then 0 minus negative 2 times 2 over 7 is 4 over 7. Next is 0 minus negative 2 times 0 is 0. And 80 minus negative 2 times 4 is 88. So do the same process till RHS. So we will proceed to our next row. So 1 half, 1 half minus 1 half times 1 is 0. Next is 1 minus 1 over 2 multiplied by 0 is 1. Then 1 over 10 minus 1 half multiplied by negative 1 over 5 is positive 1 over 5. Next is 0 minus 1 half times 2 over 7 is negative 1 over 7. Then this will be 0. Then 10 minus negative, 10 minus 1 half times 4 is 8. For the next row, we'll be doing the same process again. So this will be 0, then 0, then 4, negative 1 half minus 13 over 2 times 1, negative 1 over 5 is positive 4 over 5. Then 0 minus 13 over 2 times 2 over 7 is 13 over 7. Then 1 minus negative 13 over 2 times 0 is 1. Then 40 minus 13 over 2 times 4 is 12. So that's our final table. So when there is no negative numbers already, this time we need to stop doing the iteration or the tableau. So the next step is we need to get the right hand side of the z, x sub 2, x sub 1, and the slot 3. So here, z, x sub 2, x sub 1, and the s3. So the value of z, we have 88. So we simply put here the 88. Then x sub 2, which is 8. Then x sub 1 is 4. Then s sub 3 is 14. So just substitute the value. So from 5 x sub 1, we just substitute the value of x sub 1 here. So it will be 5 times 4 plus 10 times 8. So 8 is the value of x sub 2. So 10 x sub 2, so it will become 10 times 8 is equals to 100. So it is equal, then 7 times 4 plus 7 times 8 is equals to 84. So 9 times 4 plus 5 times 8 is 76. So it is not equal to 90. For us to get the 90, this is the use of our slot 3, which is the unused minutes. So 76 plus 4 is 90. For us, this is the use of our slot 3 for us to make our value equal. So this is now equal 90 and 90. So for the conclusion, Gina should produce 4 cases of men's shampoo per day and 8 cases of women's shampoo per day to maximize the profit of unused packing capacity. So for our problem number 2, Sia is a production manager of underarm deodorant and he wants to determine the production mix that will result in maximum profit. She is able to determine the data necessary for her to make a decision. It will take 5 minutes to mix one bottle of men's shampoo and 10 minutes to mix 4 bottles of women's underarm deodorant, and she has a total of 110 minutes available for mixing process per day. It will take 7 minutes to bottle the one bottle of men's underarm deodorant and 7 minutes to bottle the 2 bottles of women's underarm deodorant, and she has a total of 84 minutes available for bottling process per day. It will take 9 minutes to pack one bottle for men's underarm deodorant and 5 minutes to pack women's deodorant, and she has a total of 90 minutes available for packing process per day. She will she will earn 12 pesos for every bottle of men's deodorant produced and 16 for every bottle of women's deodorant produced. So we will be doing the same step on how to solve the problem from our last problem. So first we need to find the objective function, which is mx sub 2 is equals to 12x sub 1 plus 16x sub 2. Then the constraint is 5x sub 1 plus 10x sub 2 is equals to 110 for mixing process. Then 7x sub 1 plus 7x sub 2 is equals to 84 for bottling process, and 9x sub 1 plus 5x sub 2 is equals to 90 for packing process. Then x sub 1 and x sub 2 is equals to 0. Then we need to set up the objective function. So this is now our objective function. Next, we will write our objective function as, so our objective function is 12x sub 1 plus 16x sub 2. So we will transpose this as what I've said. Every time we transpose positive value to another side, so it will become negative. So z minus 12x sub 1 minus 16x sub 2 is equals to 0. So we will be doing or creating our tableau again for alteration 1. So we just distribute the values to our table. So this is negative 12, negative 16, 0, 0, 0, and our RHS is 0. For our x sub 1, which is 5, since it is 5x sub 1. Next is 10, then 1, 0, 0, and RHS is 110. For our S sub 2, 7, 7, 1, 0, 8, 0, and 84. For our uh, last constraint, so we have 9, 5, 0, 0, 1, and 90. So we just simply distribute or place the number in the variable, and I mean in the tableau. So again, we will be using the Gauss-Jordan rope operation. So we need to find the intersection here. So next is we will be identifying the most negative coefficients. Our most negative coefficient here is 16. Then we will be getting our minimum positive ratio. So we just simply, for us to get our minimum positive ratio, we just simply divide RHS to our pivot column. So 110 divided by 10 is 11. Then 12, 84 divided by 7 is 12. Then 90 divided by 18 is, 9 is 18. So this is our tableau now. So this is our pivot column and our pivot row. Next, we will be getting our value of our x sub 2. So from s sub 1, it will become x sub 2. So it is the same process. New pivot row is equals to current pivot row divided by pivot element. So 5 divided by 10 is 1 over 2, or 1/2. Then 10, 1 over 10, 0, 0, and 10. Next is, we'll find the value now of z. So, it's the same process. For you to get the new row, you should uh, subtract current row from positive column coefficient, then multiply to new pivot row. So negative 12 minus negative 16 times 1 half is negative 4. Next is negative 16 minus negative 16 times 1 is 0. Then 0 minus negative 16 times 1 over 10 is 8 over 5. Then 0, then 0, then 0 minus negative 16 times 11 is 176. Next is we'll be getting the value of s sub 2. So 7 minus 7 times 1 half is 7 over 2. Then 0, then 0 minus 7 times 1 over 10 is negative 7 over 10. Then 1 minus 7 times 0 is 1. Then 0 minus 7 times 0 is 0. Then 84 minus 7 times 10 is 7. For our last constraint, or the s sub 3, 9 minus 5 is 9 minus 5 times 1 half is 13 over 2. Then this will be 0. So 0 minus 5 times 1 over 10 is equals to negative 1 over 2, or negative 1 half. Then this will be 0, then 1, then 90 minus 5 times 11 is 35. So this is our iteration 1 over 2. So we will repeat the step. Okay. 7 divided by 7 over 2. Next is 7 over 2 divided by 7 over 2 is 1. Then this will be 0. Then negative 1 over 5. Then 2 over 7. Then 0. Then 2. Next is, we will solve for our value of z. So negative 4, so it's the same process. So negative 4, which is our current row, minus negative 4 also, so it will become 0. Then this will be 4 over 5, then 4 over 7, then 0, then 84, then do the same process. So this will be 0, then 1 minus 1 half is 1. 1 minus 1 half times 1. 0 is 1. Then 1 minus 1 over 10 minus 1 half times negative of 1 over 5 is positive 1 over 5. Then 0 minus 1 half times 2 over 7 is 1 over 7, negative 1 over 7. Then 0 minus 1 half times 0 is 0. 11 minus 1 half times 2 is 10. Next is 0. So 13 over 2 minus 13 over 2 times 1 is, this will be 0. Then 0 minus 13 over 2 times 0 is 0 also. So negative 1 over 2 minus 13 over 2 times 1, negative 1 over 5 is 4 over 5. Next is 0 minus 13 over 2 times 2 over 7, so it will become negative 13 over 7. So 1 minus 13 over 2 times 0 is 1. Then 35 minus 13 over 2 times 2 is 22. So that is our final tableau. So when there is no negative numbers already, this time we need to stop doing the iteration or the tableau. Next step is we need to get the right hand side of the x and x sub 2, I mean the z, and x sub 2, x sub 1, and s sub 3, which is our slack variable. So z is equals to 184. Then x sub 2 is 10, x sub 1 is 2, s sub 3 is 22. So substitute the value. So we just simply substitute the value of 5x sub 1. So x sub 1 is 2 bottles. So it will become 5 times 2 plus 10 times 10, because the value of x sub 2 is 10, is equals to 110. So 7 times 2 plus 7 times 10 is 84, and 90 times 2 plus 5 times 10 is equals to 68. So it is not equal. For us uh to get the value equal, we should simply add our slack, which is the 22. So 68 plus 22, it is equals to 90. So this is now equal. So for our conclusion, Sia should produce 2 cases of I mean underarm deodorant per day, and 10 bottles of cases of women's underarm per day, underarm deodorant per day, to maximize the profit of unused packing capacity. For our next problem, so problem number 3, it's also the same. Joshua is a production manager of perfume, and he wants to determine the production mix that will result in a maximum profit. He is able to determine the data necessary for him to make a decision. It will take 5 minutes to mix 1 case of men's perfume and 10 minutes to mix 2 cases of women's perfume, and he has a total of 100 minutes available for mixing process per day, and it will take 7 minutes to bottle the 1 case of men's perfume and 7 minutes to bottle the 1 case of women's perfume, and he has a total of 84 minutes available for bottling process per day. It will take 9 minutes to pack 1 case of one men's perfume and 5 minutes to pack women's perfumes, and he has a total of 90 minutes available for packing process per day. He will earn 6 pesos for every cases of men's perfume produced and 8 pesos for every case of women's perfume produced. So it's the same process. The objective function is max sub 2 is equals to x sub 1 plus 8 x sub 2. So this is our constraints. So let's proceed. So we should set up our function where 0 is assigned profit for our unit of slack variable. So next we will write our objective equation as this one. Mx max z is equals to 6x sub 1 plus 8x sub 2, then transpose to other side, so it will become negative 6 minus 8x sub 2 is equals to 0. So we just simply distribute the numbers. So negative 6, negative 8, 0, 0, 0, 5, 10, 1, 0, 0, and 100. For our S sub 2, 7, 7, 1, 0, 0, and 84. Next is 9, 5, 0, 0, 1, and 90. Next is we will be using again the Gauss-Jordan row operation for us to identify the pivot column and the living variable as the pivot row. So this is our pivot column now. We need to find the most negative coefficient. So the most negative here is -8. Then we should find our minimum positive ratio. So our minimum positive ratio here is 10. So this is our pivot row, pivot column. So we need to get the value of our S sub 1. So so we will be doing the same process as what process that in our last line, our last problem. So it is 1/2, then 1, then 1/10, then 0, 0, and 10. Next is, so we need to find the value of z. So the value of z here, for us to get the value of z, or the current row is subtracted from pivot column coefficient, then multiplied out to our new pivot row. So the answer of this is 2, then 0, 4/5, 0, 0, 80. Next is, so this will become 7/2, then 0, then -7/10, then 1, 0, and 14. Next, for our S sub 3, so 9 minus 5 times 1/2, so it will become 13/2, then 0, then -1/2, 0, 1, and 40. So this is our iteration 1. So let's continue for our iteration 2. So find the most negative, which is the -2. So our so our so this is our minimum positive ratio, the S sub 2. So you'll be getting the value of S sub 2. So this will become X sub 1. So this will be 1, 0, -1/5, 2/7, 0, and 4. Then we will get the value of z, -2 minus -2. So this will be 0, then 0, then 2/5, then 4/7, then 0, then 88. So do the same process till RHS. So this will be 0, 1, then 1/5, then -1/7, 0, and 8. Next is for our last last constraint. So this will be 0, 0, then 4/5, 13/7, 1, and 12. So when there is no negative numbers already, this time we need to stop doing the iteration or the tableau. Next step is we need to get the right hand side of the z, x sub 2, x sub 1, and the slot 3. So the value of z here is 88, x sub 2 the value is 8, then x sub 1 is 4, x sub 3 is 14. So we just simply substitute the value. So it will become 5 times 4 plus 10 times 8 is equals to 100. 7 times 4 plus 7 times 8 is equals to 84. 9 times 4 plus 5 times 8 is equals to 76. So it is not equal. So we simply add the value of S3, which is the 14. So it will become 90. So it is equal now. So for the conclusion, Joshua should produce 4 cases of men perfume and per day and 8 cases of women's perfume per day to maximize the profit of a news packing capacity. So that's all for linear programming using simplex maximization method that contains equal symbol.